The purpose of this video is to provide an introduction to cross-pole jamming against a seeker which uses a circularly polarized antenna. So here's a 30-second summary in 4 points, and the details follow. Point 1. Yes, it's possible to do cross-pole jamming against a circularly polarized seeker. Point 2. There appears to be at least one circularly polarized seeker, Neptune, by Ukraine, with probably more on the way or already here, and I think driven by technology for 5G and driverless cars, it looks like. Point 3. Whereas cross-pole against a linearly polarized radar requires an RF repeater, a horn, and a motor, to counter a circular polarization requires 2 digital RF memories and a dual polarized transmit antenna, and obviously both require software. But, point 4, the principles for cognitive control of the jammer are the same for linear and circular polarization. It's more or less the same story for both. So here are the details. Up until now, every anti-ship missile I'm familiar with has a linear polarization. The seeker uses either horizontal polarization or vertical polarization. But now it looks like there is at least one circularly polarized anti-ship missile and maybe a bunch of others, that are either here or on the way. I saw a photo of the Neptune seeker antenna on the internet. I'll put a link in the video description. Neptune is a Ukrainian missile that sank the Moskva in the Black Sea near Odessa on the 14th of April 2022. The seeker is a flat plate array design where each radiating element appears to be a hexagonal microstrip antenna in a resonant cavity. Now, after doing some online research and consulting an expert at the University of Calgary, Dr. John Nielsen, it appears that the seeker is circularly polarized. From the open literature, it looks to me like this missile technology is coming from advances in 5G and driverless cars, believe it or not. There's even an open literature paper about how to design a monopulse antenna using a flat array of microstrip patches at Ka band. That's 35 gigahertz. And there are other seekers that may have similar antenna designs produced by India and China and probably Russia at least. Now, it is possible to use cross-pole against circularly polarized antennas. If you look at the cross-pole video, it explains where the cross-polar response comes from and for linearly polarized antennas. Here's how it works. Think of the feed for a reflector antenna as a pair of crossed dipoles, one for horizontal polarization and one for vertical, and they are excited so the E fields are phase shifted from each other by plus 90 degrees for right-hand circular polarization and minus 90 degrees for left-hand circular. Now, as before, think of the dipole polarization as little arrows impressed on a sphere pointing from one pole to the other. We can draw the E field vectors on the reflector as before, and again notice that the E fields from each dipole has little cross-polar components in the quadrants. And so it goes just as explained previously, except that it's happening in horizontal and vertical polarizations at the same time. The previous video alluded to an integrated theory, a new way of understanding how cross-pole works and how we can use it for ship defense against missile attack. And that theory also applies to circularly polarized seekers. The breakthrough insight is that all seekers, and I mean all seekers, respond the same way to cross-pole jamming. The only difference is how big the response is. It's as though they're all singing from the same song sheet, just at different volume levels, and that is a very good analogy. Now, confusion has arisen in the past because of a failure to understand this point and because of the absence of a predictively useful theory, a way of understanding what's going on based on a set of rules instead of trying to, understand a disconnected set of observations. And also because of an understandable failure to recognize patterns in seeker angle response to cross-pole jamming, even though those patterns have been staring us in the face for decades, have been staring me in the face for decades. I can remember experiments in the 1990s where I thought I knew what was going on, but I really didn't. But even then, even though I thought I knew what was happening, there were head-scratching moments like, why did it do that? But looking back, and with the benefit of this insight, those observations, as best I can remember them, make complete sense. Now, this has been a remarkable set of discoveries in my life,
Like, why is it that all these seekers behave the same way in response to cross-pole jamming, even though the seekers come from different countries and different eras and have different antenna designs and different radome shapes and fabrication methods? Why are they all behaving the same way? And that is a very interesting question, which has a rich and interesting set of answers.
So how would we build a cross-pole jammer against circularly polarized seekers? Well, it's easy to make a cross-pole jammer against a linearly polarized seeker. All you need is a horn antenna and a gear assembly and a motor. To counter circularly polarized seeker, it's a bit more involved. The jammer needs two digital RF memory channels operating together so it constructs circular and elliptical polarizations and linear polarizations. And that can be made to work against seekers with any polarization, linear or circular. There are no elliptically polarized radars, just to be clear. As a final point, irrespective of the polarization of the seeker, the same target discriminants described for decoys and chaff clouds also apply to an active onboard jammer, but those can be mitigated by the jammer, including the glint discriminant. But I am not going to describe those methods here, and they could also be applied to offboard decoys, as I mentioned. Crosspol is not a single final solution. It is a powerful, flexible technique that can perform an essential function: peel the seeker antenna off the ship and get the missile heading in the wrong direction. Now, it needs to be combined with other technologies, and here's a list. A short list, just 2 items: a digital RF memory and an intelligent jog detector. However, it's an enabler for several other technologies which are in hand right now, including a pointing error estimator, a multipath estimator, a passive range estimator, and a formalization of missile soft kill. The reason it's an enabler of these technologies is because these things will do nothing for you without Crosspol's main distinguishing characteristic. It is absolutely essential that the seeker antenna be moved off the ship and ultimately cause the missile to develop an unrecoverable heading error. And this concludes a very brief overview of cross-pole jamming against a circularly polarized seeker, or frankly, a circular polarized tracking radar of any kind.